In microeconomic theory, an indifference curve is a graph showing different bundles of goods between which a consumer is indifferent. That is, at each point on the curve, the consumer has no preference for one bundle over another. One can equivalently refer to each point on the indifference curve as rendering the same level of utility satisfaction for the consumer. In other words, an indifference curve is the locus of various points showing different combinations of two goods providing equal utility to the consumer. Utility is then a device to represent preferences rather than something from which preferences come. The main use of indifference curves is in the representation of potentially observable demand patterns for individual consumers over commodity bundles. There are infinitely many indifference curves, one passes through each combination. A collection of selected indifference curves, illustrated graphically, is referred to as an indifference map. A graph of indifference curves for several utility levels of an individual consumer is called an indifference map. Points yielding different utility levels are each associated with distinct indifference curves, and these indifference curves on the indifference map are like contour lines on a topographical map. Each point on the curve represents the same elevation. If you move off an indifference curve traveling in a northeast direction, assuming positive marginal utility for the goods, you are essentially climbing a mound of utility. The higher you go, the greater the level of utility. The non-satiation requirement means that you will never reach the top, or a bliss point, a consumption bundle that is preferred to all others. Indifference curves are typically represented to be 1. Defined only in the non-negative quadrant of commodity quantities, that is, the possibility of having negative quantities of any good is ignored. 2. Negatively slept. That is, as quantity consumed of one good, X, increases, total satisfaction would increase if not offset by a decrease in the quantity consumed of the other good, Y. Equivalently, satiation, such that more of either good or both is equally preferred to no increase, is excluded. If utility U equals F, X, Y, U, in the third dimension, does not have a local maximum for any X and Y values. The negative slope of the indifference curve reflects the assumption of the monotonicity of consumers' preferences, which generates monotonically increasing utility functions, and the assumption of non-satiation. Marginal utility for all goods is always positive. An upward-sloping indifference curve would imply that a consumer is indifferent between a bundle A and another bundle B because they lie on the same indifference curve, even in the case in which the quantity of both goods in bundle B is higher. Because of monotonicity of preferences and non-satiation, a bundle with more of both goods must be preferred to one with less of both. Thus the first bundle must yield a higher utility, and lie on a different indifference curve at a higher utility level. The negative slope of the indifference curve implies that the marginal rate of substitution is always positive. 3. Complete, such that all points on an indifference curve are ranked equally preferred and ranked either more or less preferred than every other point not on the curve. So, with 2. No two curves can intersect, otherwise non-satiation would be violated. 4. Transitive with respect to points on distinct indifference curves. That is, if each point on I2 is strictly preferred to each point on I1, and each point on I3 is preferred to each point on I2, each point on I3 is preferred to each point on I1. A negative slope and transitivity exclude indifference curves crossing, since straight lines from the origin on both sides of where they crossed would give opposite and intransitive preference rankings. 5. Strictly convex. With 2. Convex preferences imply that the indifference curves cannot be concave to the origin, that is, they will either be straight lines or bulge toward the origin of the indifference curve. If the latter is the case, then as a consumer decreases consumption of one good in successive units, successively larger doses of the other good are required to keep satisfaction unchanged. Consumer theory uses indifference curves and budget constraints to generate consumer demand curves. For a single consumer, this is a relatively simple process. First, let one good be an example market, for example, carrots, and let the other be a composite of all other goods. Budget constraints give a straight line on the indifference map showing all the possible distributions between the two goods. The point of maximum utility is then the point at which an indifference curve is tangent to the budget line. Illustrated. This follows from common sense. If the market values a good more than the household will sell it. If the market values a good less than the household will buy it. The process then continues until the market's and household's marginal rates of substitution are equal. Now, if the price of carrots were to change, and the price of all other goods were to remain constant, the gradient of the budget line would also change, leading to a different point of tangency and a different quantity demanded. These price/quantity combinations can then be used to deduce a full demand curve. A line connecting all points of tangency between the indifference curve and the budget constraint is called the expansion path.